The next part of the lesson is dealing with solving absolute value equations. So an absolute value equation can have two solutions since, again, our answer represents the distance on either side of 0. Okay? So if we were solving an equation, so again, what number or numbers from 0 are equal to 5? Okay? So what numbers are 5 units away from 0? So we would have two answers, positive 5 and negative 5. Now, if we make the equation a little bit more complicated, so this is asking us, well, how many numbers are 5 units away from 0, but we're going to also add 3 to both of those numbers. So the easiest way to solve them is to actually take this, and we're going to write two separate equations without our absolute value sign. So the first one is pretty easy because we're just trying to figure out how far this part inside is, how many 5 units away is it from 0. So I would just take that equation and write it as x plus 3 equals 5. And then we would solve that like a normal equation, so we would subtract the 3. So we would get x equals 2 for our first answer. Now for the second one, the second equation, so we always solve 2, we're going to take whatever's inside our absolute value, rewrite it again, so x plus 3, and then everything on the right side, we're going to make it the opposite sign. So this would be equal to negative 5. So, and then we just solve that one. So we would subtract the 3 over. So x equals negative 8. So we have two answers, 2 and negative 8. So whenever we're solving absolute value equations, we're really solving two equations every single time. Now we should check our answers just to make sure they work. And the situations that we need to check them in is if there's a variable on this side or if this is negative. So those are the two cases where you need to make sure that you are checking your solutions. All right, so let's do some examples. All right, so again, I'm solving an absolute value equation. So I'm going to write two equations, and then I'm going to solve them each. So first one, we just take, again, exactly what's inside our absolute value. So 3x plus 2, and then equals 7. And then the second equation that we're going to solve, again, we just keep this the same. So 3x plus 2 equals, and then we change everything on the right side to its opposite sign. So in this case, it'll be a negative 7. All right, and now we're just going to solve. So I'm going to draw a line down the middle so I know I'm solving two separate equations. So first thing, we subtract. So 3x equals 5. And then we divide by 3 to each side. So we can't simplify that fraction, so we're just going to leave it. So our first answer is x equals 5 thirds. And then we go to our next equation and solve that one. So again, we have to start by subtracting 2. So 3x equals negative 9. Divide by 3. So x equals negative 3. So we have two answers, 5 thirds and negative 3. All right, next one, if we notice, we have some extra stuff here. So before we actually write our two equations, we always need to isolate our absolute value symbol. That'll make it the easiest, okay? So that means I'm going to start by adding 5 to both sides. So now we have 3 times the absolute value of 4w minus 1 equals 15. And then again, I need to get that absolute value equation alone before I can continue. So you always isolate the absolute value before we write our two equations. So now we have to divide by 3. And again, remember, we can't distribute that in. That's not allowed with absolute values. So now the equation that we want to look at is the absolute value of 4w minus 1 equals 5. So this is the equation that we want to use to write our two separate ones and solve. So we're going to solve 4w minus 1 equals positive 5. And then 4w minus 1 equals negative 5. So again, we're just making it the opposite sign here. So start by adding 1 to each side. So 4w equals 6. divide by 4. So again, we're going to end up with a fraction for an answer, and that's fine. So we just got to make sure we reduce it. So 6/4 can be reduced to 3/2. So that's one of our answers. And now we're solving our second equation. So again, we're going to start by adding. So 4w equals -4. Divide both sides by 4. So w is going to be equal to -1. So again, we have our two answers. All right, next one. So it looks like we don't have to isolate our absolute value, but for this one, we do need to check our solution because we have an x on this side. So this side might accidentally end up being negative, and an absolute value can't equal a negative number. It always has to be equal to a positive number. Okay. So let's start by writing our two equations. So first one, 2x plus 5 equals 3x plus 4. And I'm going to put a little line here. 2x plus 5 equals, and again, we have to change everything on this side to its opposite. So both of these are going to become negative. So equals -3x minus 4. And now we solve each one. So since we have x's on each side of our equation, that means that we need to get x's on one side, numbers on the other. So I'm going to start by subtracting 3x. And then I'm also going to subtract the 5 at the same time. So again, if you need to do that in 2 steps, that's completely fine. All right, so 2x minus 3x is a negative x. Positive 5 minus 5 cancels out. 3x minus 3x cancels out. And then positive 4 minus 5 is -1. So now we divide both sides by -1 to make our x positive. So x will equal +1. Next one, same thing, x is on one side, numbers on the other. So we're going to add 3x to each side. Subtract 5 at the same time. So here we're going to have 5x. That cancels, equals, cancels. -4 minus 5 is -9, so we're going to end up with another fraction. So I divide both sides by 5. So x equals -9/5. Now before we actually circle these to indicate that there are final answers, we have to check to make sure that they both work. Okay, so I'm going to write check here, so we're going to check. Now when we check, we always check back to the original. Okay? Always check the original. So I'm going to substitute 1 in for both x's and simplify to see if I have a true statement. So absolute value of 2 times 1 plus 5 equals 3 times 1 plus 4. So I'm going to do a little bit of simplifying in my head. So I know that 2 times 1 is 2, and then if I add it to 5, that'll give me 7. So we have the absolute value of 7 equals, and again, 3 times 1 is 3, plus 4 is 7. So the absolute value is equal to 7. So this one works. So I know that this is an answer. So I'm going to circle it. And then I'm going to do the same thing to the next problem. Okay, so I'm going to draw a little line here to divide my work. So I'm substituting -9/5 into both of the x's. So 2 times -9/5 plus 5 equals 3 times -9/5 plus 4. So I'm actually going to simplify the right side first. And I'm going to cheat a little bit because I know I'm going to be dealing with fractions. So I'm actually going to put my 4 over 1 right away. And I'm going to switch this to have a denominator of 5. So that means that I'm going to take each of these times 5. So now we have 20/5 instead. And then on this one, so we distribute the 3 to the 9, so this is really 3 over 1. So 3 times -9 is going to be -27 over 5. And then if I combine those together, that's going to combine to be -7. So we're just dealing with the numerators now since we're adding. So -7/5. Well, I don't even have to worry about simplifying the other side because I now have an absolute value So that 2 times negative 9/5, it doesn't matter what I have in it. I have an absolute value of something equal to a negative number. That can't happen. So this solution doesn't actually work. So since it doesn't work, I'm going to cross it off instead. So really, we only have one answer that works for this problem. So we would call this an extraneous solution. All right, let's try another one. So looking at problem 8. So again, before we start anything, we have to get that absolute value by itself. So I'm going to start by subtracting 1 to each side. Now, there's nothing to combine it with on this side. So we're going to have 3x minus 4 on an absolute value equals negative 4x minus 1, since we can't combine it. So this is the equation that I want to look at. Okay. So to write our two separate equations, I'm going to make a little box here so we don't get our work confused. So again, writing our two equations, we need to solve 3x minus 4 equals negative 4x minus 1. And we need to solve 3x minus 4 equals, and again, we're changing these to the opposite sign. So we're just multiplying everything by a negative 1. So this will become a positive 4x plus 1. Okay, so again, x is on one side, numbers on the other. So we're going to add 4x to both sides. At the same time, we're going to add 4. So that gives us 7x, cancels, equals, cancels, 3, divide by 7. So we end up with x equals 3/7. And then next one, so again, numbers on one side, variables on the other. So we're going to subtract 4x, add 4 again. So now we have negative x. That's going to cancel. That one cancels, equals 5. So now we just have to divide by negative 1 to make our x positive. So x equals negative 5. We have a positive divided by a negative. Again, I don't want to circle anything yet because I don't know if we have solutions. So since we have a variable on the right side, outside of our absolute value, we have to check to make sure that they both work. So I'm going to start with the easier one here. So again, we're going to substitute it in. I'm going to do a little bit of mental math here. So we're replacing that x with negative 5. So that means that we have negative 15 here minus 4 equals, and again, if we substitute here, that's going to give us a positive because we're taking a negative times a negative. So positive 20 minus 1. Well, if I look here, this is going to be a negative 19. And then here, this is a positive 19. Well, when we take the absolute value, this side is going to become positive, so I know this is going to work. So that means that x equals negative 5 is a solution. So now we have to check the 3/7. So again, I'm going to actually start on this side of the equation when I check it because I don't think it's going to work out very nicely. So that means that we have to take negative 4 times 3/7, and then we're subtracting 1. Well, again, I'm going to cheat a little bit. I'm going to work ahead, and I'm just going to make this a fraction right away. So 7 is my denominator, so we're really subtracting 7 over 7. So again, simplifying, this becomes negative 12 over 7 minus 7 over 7. Well, when I combine those, that's going to combine to be a negative 19 over 7. Well, that means, again, I'm going to have an absolute value of something, I don't even know what, equal to a negative number. That's not going to work. So that means that this is not a solution. It's not going to work, so I'm going to cross it off. Okay, so we only have one solution again for this problem. All right, and our last problem for this section, we have the absolute value of 3x equal to negative 12. Well, if I'm looking at this, I have an absolute value equal to a negative number. I don't even need to do any work because that's not allowed. That can't happen. It has to be equal to a positive. So I'm just going to write no solution. I don't have to do any work for that one. So make sure you're paying attention to those simple things to make your work lives a lot easier when you're solving. So again, just to kind of recap, when you're solving absolute values, you have to isolate your absolute value first and then go into your two equations. If you have a variable outside of your absolute value symbol, you must check your work